So we're going to solve and graph. The absolute value of the difference between x and 9 is greater than or equal to 1. And we're going to do a case 1 and a case 2. So case 1 is simply going to be x minus 9 is greater than or equal to 1. And then case 2 is going to be negative x plus 9 is greater than or equal to 1. Notice here on case 2 I flipped the sign of every term inside of the absolute value, and that's how we get this inequality here. So now we're going to solve both of them, or at least isolate the variable, and so we'll do that by adding 9 to both sides of the inequality, giving us x is greater than or equal to 10. And then we're going to move on to case 2, where we're going to subtract 9 from both sides of the inequality, leaving negative x is greater than or equal to negative 8. Now we're going to divide by the coefficient in front of the x, which is negative 1, leaving us with positive x. And now, since we divided both sides by a negative number, the inequality is going to switch from greater than or equal to less than or equal to, and we have a negative 8 divided by a negative 1 is positive 8. So we have our two inequalities, and this here is an OR, right? We want to remember that when we have absolute value in the inequality, when we have a case 1, case 2, it's OR. So the answer here is x is greater than or equal to 10, or x is less than or equal to 8. So what is our solution set? Curly bracket x such that x is greater than or equal to 10, or x is less than or equal to 8, curly bracket, is our solution set. Let's go ahead and graph it now, starting with x is greater than or equal to 10. We'll put a closed circle on 10, and our arrow is moving to the right. The second inequality, x is less than or equal to 8, we'll put a closed circle on 8, and the arrow is moving to the left, like so. Let's go ahead and try this again on example number 8. We have the absolute value of the difference of 3x and 2 is greater than 4. So we'll do a case 1 where we just take away the absolute value sign, and our case 2 where we flip the sign of each term in the absolute value. So it's going to be negative 3x plus 2 is greater than 4. And when we do a case 1 and case 2, it is an OR, right? So we're going to put an OR in between the two. Let's solve case 1 by adding 2 to both sides of the inequality. We get 3x is greater than 6. Now we'll divide by the coefficient 3, and we'll get x is greater than 2. And then for case 2, we'll do the same thing. We'll subtract 2 from both sides of the inequality, leaving us with negative 3x is greater than 2. We'll divide by the coefficient negative 3, and we'll be left with positive x is greater than negative 2 over 3. So what is our solution set? It is curly bracket all x such that x is greater than 2, or x is, here when we divided by a negative 3, I forgot to flip the sign. So this is not greater than anymore, right? This is going to be a less than, right? So I made that mistake. So here in my solution set, it's going to be all x such that x is greater than 2, or x is less than negative 2 over 3, curly bracket. Alright, so now let's go ahead and graph these inequalities. We'll start with x is greater than 2. We'll put a open circle on 2, and the arrow moves to the right. And then for negative 2 over 3, that's going to be right over here. Right about here is negative 2 over 3. Oh no, I'm sorry. It is right over here. Negative 2 over 3. So I will put a open circle on 2 over 3, negative 2 over 3, and my arrow is moving to the left, like so.